If you've ever picked up a shiny brass key or admired a bronze statue, you've already encountered two of the oldest engineered materials in human history. They look similar, both warm-toned, both metallic, but they're actually quite different in composition, properties, and how they're made. So how exactly do we turn raw metals into brass and bronze? And why have these alloys stuck around for thousands of years? Today, we're diving into the fascinating process behind how brass and bronze are made, from ancient furnaces to modern industrial production, right here on History of Simple Things. Long before modern factories existed, humans were already experimenting with metal combinations. Bronze came first. Around 3,300 BCE, civilizations in places like Mesopotamia discovered that mixing copper with tin created a much stronger material than copper alone. This breakthrough was so significant that it defined an entire era, the Bronze Age. Tools, weapons, and even early art were made from bronze because of its durability and resistance to wear. Brass, on the other hand, came later. Ancient civilizations like the Romans produced early forms of brass by heating copper with zinc ores, although they didn't fully understand the chemistry behind it. By the medieval period, brass-making techniques became more refined, especially in Europe. Eventually, with the discovery of pure zinc in the 18th century, brass production became more controlled and consistent, leading to the wide range of brass alloys we use today. At their core, both brass and bronze are alloys, meaning they're made by combining a base metal with other elements to improve its properties. Copper is the main ingredient in both. Brass is primarily a mixture of copper and zinc. The amount of zinc can vary, usually between about 5% and 40%, depending on the desired characteristics. More zinc generally makes the brass stronger and more workable, but slightly less corrosion-resistant. Bronze, meanwhile, is traditionally made from copper and tin. Tin content typically ranges from around 5% to 12%, though modern bronzes can include other elements like aluminum, silicon, or phosphorus. These additions can enhance specific traits such as strength, hardness, or resistance to corrosion. Everything starts with raw metals. Copper is extracted from ores like chalcopyrite through mining, crushing, and smelting. Zinc and tin are also obtained from their respective ores, sphalerite for zinc and cassiterite for tin. Once extracted, these metals are refined into a relatively pure form. Purity matters because even small impurities can affect the final alloy's strength, color, or melting behavior. In modern facilities, metals are tested and carefully measured before they're combined. To make brass or bronze, the base metal, copper, is melted first. Copper has a melting point of about 1,085 degrees Celsius, so industrial furnaces must reach extremely high temperatures. For brass, zinc is added to the molten copper. This step requires precision because zinc has a much lower boiling point, around 907 degrees Celsius. If the temperature isn't controlled properly, the zinc can vaporize and be lost as gas. To prevent this, manufacturers often add zinc in controlled environments or use pre-alloyed materials. For bronze, the process is slightly simpler. Tin has a lower melting point than copper, so it melts easily into the liquid copper without the same risk of vaporization. The molten mixture is stirred to ensure even distribution, creating a uniform alloy. Once the molten alloy is ready, it's poured into molds, a process known as casting. This can be done in several ways depending on the final product. For intricate shapes like statues or decorative items, sand casting or investment casting is often used. Molten bronze or brass is poured into a mold cavity and left to cool and solidify. This method has been used for thousands of years and is still widely used today for artistic and industrial applications. For more standardized shapes like rods, sheets, or pipes, the metal may be cast into simple forms called billets or ingots. These are then processed further through rolling, extrusion, or forging to achieve the desired dimensions and mechanical properties. After casting, the metal is allowed to cool. The cooling rate can affect the internal structure of the alloy, which in turn influences its strength and durability. Controlled cooling helps prevent defects like cracks or uneven grain structures. Once solidified, the metal often undergoes additional treatments. These can include machining, polishing, or heat treatment. Brass, for example, is often polished to achieve its characteristic bright gold-like appearance. Bronze, especially in sculptures, may be treated with chemicals to create a patina, a surface layer that gives it that classic aged look. One of the most interesting aspects of brass and bronze is how small changes in composition can dramatically alter their properties. Brass is known for its malleability and acoustic qualities, which is why it's commonly used in musical instruments like trumpets and saxophones. It's also resistant to corrosion, making it ideal for plumbing fittings and marine hardware. Bronze, on the other hand, is typically harder and more wear-resistant. It's often used in applications like bearings, bushings, and ship propellers. Its resistance to corrosion, especially in seawater, has made it a favorite material for centuries. From ancient tools to modern engineering, brass and bronze have proven their value time and time again. What started as simple experiments with copper evolved into two of the most versatile materials ever created. And while the basic idea, melting and mixing metals, hasn't changed much over thousands of years, the precision and control we have today make these alloys more reliable and useful than ever. So the next time you see a brass instrument or a bronze statue, you're not just looking at metal. You're looking at thousands of years of human innovation refined in fire. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.